So let's start with the distance between a line and a point. Let's say we're given a line ax plus by plus c equals 0, and a point, we'll call it x1 comma y1. The distance is the absolute value of a times x1 plus b times y1 plus c all over the square root of a squared plus b squared. A good way to memorize this formula is to multiply the x's, so the coefficient of x and with a point x. So that would just be ax1, then plus the coefficient of y with a point y, and you don't want to forget c. Okay, so c has nothing to be multiplied here, so we'll just leave it as c. Always take the absolute value because it doesn't make sense to take absolute value or take a negative distance. So the absolute value will always make it positive. And then we're just going to take the square root of a squared plus b squared. So you can kind of think of this as Pythagorean theorem. You know, you have a squared plus b squared equals c squared. If you solve for c, you get the square root of a squared plus b squared. Okay, so that's how you should remember the formula. Another thing I should point out is if I let x1 and y1 be the origin, the distance becomes just the absolute value of c all over the square root of a squared plus b squared. Okay. Now let's look at some examples. Let's say we're given 4x plus 7y plus 6 equals 0, and the point we're going to use is 3 comma 2. So the distance will be the absolute value. Now we're going to multiply the coefficient of x with the point x, and then add that with a coefficient of y times the point y, and then plus the constant 6. And we're divide that over the square root of a squared plus b squared. So b here will be 7. And this reduces to 32 over the square root of 65. Now let's look at negative coefficients and negative points. So if I have negative 4x plus 3y minus 8 is 0, the point is negative 1 comma 3. Now the distance will be the absolute value. I'm going to multiply the coefficient of x with the point x, and then add that with the coefficient of y times the point y, and then we'll add the constant all over the square root of the x coefficient squared plus the y coefficient squared. So this will just be 5 over root 25, and so the distance is 1. So with the first two examples, we only looked at integers. Now let's look at fractions. So the only difference with fractions is it's just going to be messier. The algebra will not be as nice. Okay, so the first example is 1/3 x minus 2/5 y plus 1/6 equals 0, and the point is 4/5 comma negative 2/3. Okay, so the distance will be the absolute value, the coefficient of x multiplied by the point x, plus the coefficient of y times the point y, and then plus the constant. Okay, divide that over the square root of the coefficient of x squared plus the coefficient of y squared. The numerator becomes 7 over 10, and the denominator is the square root of 61 over 225. And so that simplifies to 21 times the square root of 61 over 122. And that's my final distance.